Okay, let's do problem 7. So we're simplifying radicals here. And the key thing to know when you're simplifying radicals is to keep in mind the perfect square numbers. So the perfect square numbers are 2 squared is 4, 3 squared is 9, so on and so forth. So we have 4, 9, 16, 25, 36, 49, 64, 81, and 100. Hopefully those seem relatively familiar to you, but if not, the most important ones are probably these first couple, like 4, 9, 16, and 25. The reason why these are so important when we're simplifying square roots, simplifying radicals, is because we want to take the numbers inside here, like 72 and 40, and we want to be able to divide those by one of these perfect square numbers. So 72, that one is divisible by 36. And so I can rewrite this as the square root of 36 times 2. The reason why that's nice is because we can take that 36, we know it's a nice square root, so we can take it out of the radical as a 6. So we can rewrite this as 6 times the square root of 2. Same idea with part B. Square root of 40. The thing that immediately comes to mind is this 4. We can divide 40 by 4 really easily. And so we can rewrite this as the square root of 4 times 10. We can take this out of the square root as a 2 and say 2 times the square root of 10, or 2 root 10. Okay, let's go to part C. So here we have 72, and we also have this variable x. Now, we know 72 is 6 root 2, so we can start with that right away. Now, x squared is just x times x. And so when we have x squared in the radical, we're allowed to take it out in pairs. So x squared is a pair of x's multiplied together. That means we can take this pair of x's out of the square root and leave one of them on the outside. So we get 6x root 2. Same idea for part D. We know 40, the square root of 40 is 2 times the square root of 10. So we're going to start with that. Now, y cubed is y times y times y. And so, just like in part C, we took a pair of x's out of the square root and left one x on the outside. We can do that same thing here, except only 2 of these can be taken out as a pair. So this pair of y's gets to come out, but this one has to stay by itself inside because it doesn't have a pair to come out with. So we're going to write this as 2. That pair of y's came out as 1y on the outside, and then 10y on the inside. Okay, now for part E, same idea. We know that 72 becomes 6 root 2. And we had this 3 on the outside to start here, and we have an x to start. And then we have an x squared on the inside. We know that that x squared is x times x, so we can take it out as a pair. So I'm going to cross it out on the inside, and I'm going to put an x right here on the outside. Now this is our final answer, but we just need to simplify a little bit. 3 times 6 gives us 18. X times x can be written as x squared. And then we just have our 2 on the inside. Same idea with f. We start with 2y squared on the outside. We know that the square root of 40 can be written as 2 times the square root of 10. And we have our 3 y's on the inside here for y cubed. Same idea as in part D, we can take out a pair, but this one has to be left by itself on the inside. So we're going to write this. We're going to leave one y on the inside because it didn't have a pair. And we're going to bring that pair of y's outside and write it as a single y. Now this again is our final answer, but we're going to simplify a little bit. We have 2 times 2 gives us 4 on the outside. Y squared times y gives us y to the third. And then on the inside, we're going to have 10y left. That's our final answer.